this particular application can be applied to the areas where it's a structural application. We want to know the depth of the crack. We want to know what is the depth, what is the width of the crack. So on screen, you see with a typical AI, we get these results like that, which are really an information that cannot be quantified. And with the help of a better AI models, which I will just show you, this thing can be really segmented in a very sophisticated way. And this can be applied in variety of applications. Now, similar to what I would be presenting, this application would also be valid in medical imaging. If you want to know the area covered by the tumor or some cells where you exactly want to measure their volume, this is the technique which would cover it all. So basically, I would try to tell that how to best image segmentation techniques and how to have the better boundaries around the objects which you are trying to segment. So getting back to the application, so this is the kind of images that we get in a typical reactor material after years of exposure. And here you see these images, they all are black and white. All the objects here, they have a blurry surroundings. And idea is to be able to have a model that segments them automatically and accurately. Now, I will touch little basics that how does CNN works, because just I did not know what kind of audience I would be talking to today. So we all know what is CNN a little bit. It's been in media, it's been everywhere, especially for the people who are AI enthusiasts. So CNN is convolutional neural network.
Yeah, that one was better. Yeah, that was the
Can you hear me better? Okay. Right, so I'm the first speaker, so everything is getting set up. Never mind. So CNN is convolutional neural network, and we all have heard about it. Let me walk you in that how does the procedure happens. So for example, to a CNN, if you give an image, if it's a dog or a cat, a CNN should be able to tell you that it's a dog or a cat. Similarly, if I'm giving the CNN various image, it should be able to tell me that these are cavity 1, cavity 2, cavity 3. So this is an image that we can give to a CNN. Now, what is a CNN? CNN is convolutional neural network. Now, neural means it has neurons into it. So a typical CNN has an input layer, hidden layer, and hidden layer can be multiple. And then we have the output layer where there is a probabilistic algorithm runs, and it literally tells you if it's a dog, bird, or a cat. And this is how the entire operation takes place. Now we'll go a little bit deep. Now, what happens if I give an image? So there is a variety of algorithm that takes place. An input image, it goes through the variety of steps. It goes through pooling, it goes through convolution, and it goes through activation functions. And then finally, we have something, we got numbers here that we put it into the flat layer, and finally we plug them into neurons. And here, finally, we get our answer. Now, this entire CNN, if you pay careful attention, it's divided into two things. One is a feature extraction, and other is a classification. So I will touch, first of all, what is a classification, and then I will talk about a little bit about what is feature extraction. Now, what happens? So if this is an image, or this is a cavity, a material cavity, or a crack, or whatever I give to the material, it's an image like that, a black and white image. Now, how does your computer read it? Your computer read it in a way that, just a very simplified example I have given, wherever there is a black color, it's 0 everywhere. And wherever there is a crack or a 2, it has a digits into it. So a computer sees this image in a form of numbers. Now what happens? It's a 2D it's a 2D matrix. Now, first thing is that we convert this 2D matrix into one-dimensional matrix. So you see here, this is a one-dimensional matrix, and all the numbers are now in one dimension. And now the image that was like this has been converted into one-dimensional number and would be plugged into neurons. Now what happens? This is a neuron. That means this is the input, which is basically all these numbers. And all these numbers, they are together fed into the next layer, which is a neuron. And now what happens into this neuron? This neuron basically, as you see here, there are nth neurons. Each neuron is connected to all the input layers. And finally, a neuron, it consists of multiplication of all the inputs from all the neurons and some kind of weights here. And together there is a bias. And finally, we get what is we call as output. So that means we will here have variety of outputs. And each neuron will have Y1, Y2, Y3. And finally, everything will be optimized through backpropagation. And we will have activation function here, which will reduce your number between 0 and 1 for easy computation. And finally, there is a probabilistic algorithm that runs, which will tell you while you train, okay, when I train my model, I gave variety of numbers 0, 1, 2, 3, 4, 5, and 9. And it will tell you out of this thing, when the weights are computed, that the probability that it is a 2 is 0.92. And that is how I know it's a crack, it's a 2, or it could be a dog or a cat. Now, coming to the first part, which is a feature extraction part, how does a feature detection takes place? How does my computer knows that what kind of image it is? So for example, now I'm moving to a number 9, or I can move to a cat or a dog. Now in a number 9, what I see is that it's got generally, we can say it got 3 features. One is this loop here, other is this line here, and then is a diagonal here. And so entire 9 is divided into these 3 features. Now, when you show the computer this image, there is something that we call something called pooling happens. Now, what happens is when we develop the algorithm, we select variety of filters. Now, these filters here, as you say, it was a 9. So 9 here, as you see, it is represented by 1, all the 1 here. And wherever there was a black, I represented by 9. It's just a representation to understand how the network works. So this is a filter. And you see here, this filter, it is a kind of a loop because we are trying to extract the loop part of the 9. So basically, this is the image the computer has. When you go into your algorithm, you decide this feature, and finally, you slide this filter on your image. And when the sliding happens, then is the term convolution, which is the multiplication of this image, the mathematics or the numbers in this image with the numbers in this filter. And then you get the numbers here. Similarly, you see here, I can run a loopy pattern filter, I can run a vertical pattern filter, I can run a diagonal pattern filter. And like this, I can have the entire image extracted. This is here in front of you is a very simple image, but we can do the same thing with either cat, dog, or whatnot. Now, here is a more general example. I run the same loopy filter. In 9, I get a 1 here. On 6, I get a 1 here because there was a loop here. 8, I run a loop here because there's 2, 1 I get here. So what is happening? It is simply the number on this screen, which consists of 8, is getting multiplied to this filter, and the convolution is happening, and features are getting extracted. And similar thing is happening is in 9 and 6. And we're getting numbers here. Okay, now going to more high resolution images and more denser images. Now this is an image of koala in front of me. And I thank Code Basics to provide this explanation. And here it's just an eye detector, which could be again a round filter, which I apply. So I put I give my CNN image, I create a filter, and I get signs, 1, 1 corresponding to the two eyes of koala. Here, 2 eyes of koala. And here, all these. And finally, to an image, I give 32 filters, 64 filters, 128 filters, and the entire map is extracted. And this is how the final overall view. We give the image, we give the filters, then the convolution happens, features are extracted, it goes here, and then these numbers, which could be a very, very large amount of numbers, now are reduced to very less numbers. And now we give them as an input in a one dimension, and we get, the entire network works. Now, there's a very thing here that a lot of people are like, we use activation functions here and pooling here. So the entire image, now after multiplying, you see that this is a big matrix of numbers. And what does this ReLU activation function does? It reduces all the number into this matrix between 0 and 1. And rest, everything is just deleted. So it is that we are really reducing our matrix. And we are really reducing the numbers that we want in our computation. And similarly, there is something that happens when this image gets reduced, a thing called pooling, where this matrix here, as you see here, it just takes the maximum numbers here and put it in a separate box. And believe me that this image that is so big is now just reduced into these many numbers. That means now we have successfully decoded our image. And now this big image, which is now converted to small, would be now going to your neurons. And finally, your CNN will work. Now, this was the image here. And similar analogy here. We have a filters, convolution happens, features are extracted, and finally, we created our algorithm. And to any people who is in AI and wants to know, hey, it looks very tricky. No, it's very simple. It's only 6 lines of code. That is there. So with AI, we are very lucky that everything is very well packaged. You don't have to do coding from scratch. So this sixth layer of code, and literally you can use it in your organization to detect any objects. So what is happening here? So model is a sequential model because we are doing here step by step everything. Now we are doing convolution, right? So this is a function here. I have given 32 filters to extract all my features. The size of my filter was 3 into 3. This is the input shape of my image, and this is the activation function. Finally, I want to reduce my image so that it becomes good for computation. I do pooling, and now I have flattened it into one dimension, and now I have selected a function, activation function, and sigmoid. And finally, this is the part which is a compiler part where we talk about the losses that a loss is computed and your metrics are computed. And this is epoch, that is the 20 times you want, as if you will give to your child that please go through this book 20 times so that he learns better. It's a similar thing that is happening with epoch. So overall, reality. Now, this was something to take you and, to develop a little idea of what I'm going to talk about. So what kind of problems that we solved with University of Berkeley and Google here? We were given these kind of very complicated images. And here you see these objects are overlapping on each other. And we wanted something that, should be an algorithm that should be able to segment these objects automatically. So even humans, when I give, if any one of you who is not a domain expert and I give you this image, you will see this image like this. And you will just paint it like this. But to a domain expert like me, I will just simply say, no, these are the 3 cavities which are overlapping on each other. So here are 4 cavities which are overlapping on each other. But look how some of the students at the university did marking for me. So this is known as object labeling. So what I am trying to do is I am giving this label to my algorithm just for 10 images. And for rest 1,000 of the images, I want my algorithm to produce all the masks. This kind of technique is easily applied when you have this Tesla driving on the road everywhere, where we give it 10 images of the road and we give 10 masks where the cars are present. And finally, it is able to tell and give the mask, if anyone has Tesla, all the time in your iPad there. So this is a training. So we are here now label data. And this is kind of answers we expect. So here, this is object detection, where I'm just detecting object. It's a very easy task. So if I just want to measure how many objects I'm detecting, this I will simply use this, and it will just give you the density. Now we go more complicated. We want something called segmentation. So in the segmentation, what happens? Every pixel should have an identity. So here you see we have a grass, and grass has an identity. Here you see everything is green in color, and the cat, everything is yellow in color, and the trees, everything is blue and pink in color. So this kind of things where every pixel is segmented is known as semantic segmentation. And then object detection, I already talked about, where you're detecting it. And instant segmentation is even further. So if an image, I have two dogs, it should be able to tell me it is a dog 1 and dog 2. And this is very much applicable if you have a parking lot and it has a 5 car, and if one is a Toyota and other is your Tesla, it should be able to immediately point out that which of the car is missing. So this is a multiple application. Entire computer vision is based on these algorithms. So finally, we are trying to do both. In these images, we are doing segmentation and object detection. There are a variety of models available. You can choose. I have chosen YOLO and Masker CNN for my instant segmentation and object detection. And for image segmentation, I have used something called UNet. So UNet is basically, I already explained, we have a big image. Finally, it is decoded into a very small numbers. And then finally, it is encoded by the algorithm. So I use the DefSegnet model, which is applied to material science. And this is the architecture it looks like. You have an image. It is now pooled, convoluted, filtered, and becomes so small that it contains all the feature for easy computation. And finally, you can decode it, and your masks are produced. Now, what happens? How do we do this? Actually, I took 100 of images, and these images I divided into train, validation, and test data set. Some of the images, I rotated them, I multiplied them, and I did image augmentation. And then we put them into this model, which is UNet, and then the final training happens. Now, when we started doing training, then the biggest challenge of the problem occurs because we have something called loss function. And finally, after training, you can compute their confusion matrix in which you can compute precision, accuracy, and everything. Now, you look here, this is the ground truth. So this was the image, and this is the ground truth. And look, the ground truth that has been marked by some of the students here, back at the university. And you see the ground truth, the students have not even separated them with the boundaries or anything. And finally, because this is the ground truth and this is the final prediction we have got. Now, everyone talks about what is the precision of my model? What is the accuracy of model? So let us look, what does precision accuracy looks like? So precision and accuracy, basically, it is made up of something called true positive, false positive, true negative, and false negative. So here, because this was the ground truth and this was actually here, the cavity was present, so we call it a true positive. But model accidentally predicted some of the areas where the cavities should not present. We call it a false positive because it's a white in color, but it is false. It should not be in the image. And here you see a clear thing that where I have overlapped the mask which has been with the image. And negative is absolutely black pixels that we want. And somewhere the model has predicted the black pixels where there should be white. So you see here. So this is what we call confusion matrix. And by calculating this false positive, true negative, false negative, believe me, entire computer vision is running. So what is happening here? You talk about accuracy. So how do we calculate accuracy basically? So just these are some formula. So where if I have my true positive, true negative, and I multiply it by all, it will be accuracy. Similarly, we can get precision recall. And we can talk about my model is successful because it has 95% accuracy, or it is much more, has higher precision if it has 98%. So this is, again, the same thing, but in more detail. Now, after this thing, now the biggest part where I really needed the help from some of the guys from Berkeley and here was in loss function. So anybody who is from computer vision, so basically what is a loss function? So loss function is that if I give a person A an image, a similar image, and a person B a similar image, and I tell them what is the difference between these two images. Some person will start counting it maybe, by just counting the objects. Some people maybe start counting the corners. So basically, how do you compare these two images? And finally, the idea is that these two images should match. So for this, we use variety of loss function. So most common one is binary cross entropy, IOU, and DICE. And this is the computer vision problem of binary classification. Why binary classification? Because each pixel can either be white or black. So here I have negative pixel or positive pixel. So some of the people who are experienced here, this also is a problem of imbalanced data set. That means here my negative pixels are much more than my white pixel. So finally, it is an imbalanced data set. It is a problem of binary classification. Therefore, I'm using this classic loss functions available in the literature to solve my problem. Now, let us look what happens here next. So this were the original image that we had. This was what my students, they gave me labeled. And then this is the predicted mask. So, and here is the overlapping. So in most of the cases, you see, this is quite a good results if we are doing in any approximate word. But in medical images, in material science, where you worry about the accuracy of even 5%, it's not a very good result. You see here, the white part is just coming outside these objects here. And therefore, the volume of the cavities that I'm receiving by these images is at least 5 to 10% off. And in the reactor material, we are looking for the precision of 2%, or sometimes even less than 1%. So this all the values are off. But overall, we have these results, and we wanted a much more precise results. Now, what is IOU? So IOU, we know that if this is a predicted mask versus this, and if they overlap totally on each other, and here they totally overlap on each other, and answer is 1, we are successful. That's what we want. We want a perfect overlapping, but we don't receive these results. So here is IOU loss that we do with 1 minus IOU. We wanted this to become 1 and loss to become 0. Now, like this, there are more losses using the same thing you see here with ground truth, using the same true positive, false negative, we get something called dice loss. And it's with the same results that we achieved. And something here I'll touch, we also have something called binary cross entropy loss, which is a probabilistic loss. So what happens is, basically, it just tells what is the probability that this pixel should be white versus black, and it tries to compare the probability difference between both these images by using this formula. Now, just if anyone is a mathematician or physics, I've just keep this formula in mind and see what what we did with the university to make it much more robust for our application. So this is here the loss, and it's just made up of 2 parts here, which is simply we are calculating the probability. I will get there in a bit. Before that, let us see, we use variety of loss functions, and our values were so good. Anyone will stop, saying, hey, it's a very good study. We are all successful. Results are 0.95. And, your recall, which is the repetition, how many times your results are getting repeated, it is very high. So, it's good. But if you look at the qualitative analysis, let us look. So this is the result from binary cross entropy, which is weighted binary cross entropy. And you just look, if you carefully look, so the one that is with the weighted binary cross entropy, it is much more broader. And then it becomes, here you see the boundaries are much more narrower. And if you see here, I just, for better visual, here is one of the artifacts. And you see here the difference. It's very clear. it gives you the precise difference of really 1 to 5%. If I try calculating it. So what we did, we created our own loss function here. Here we created something called distance loss function. So what happens is, I showed you earlier the result between two loss function, which was weighted binary cross entropy and distance loss function. So in binary cross entropy, this was the formula. So what mathematician does, they say, hey, because this is an imbalanced data sets, let us try to balance it artificially. Let us try to introduce a coefficient here. So in this formula, which was known everywhere, like this is the basic of artificial intelligence, like to have the probability difference between the two samples. And he introduces he introduces an extra coefficient here. And after introducing this extra coefficient, we just wanted to have the weighted binary cross. So this is just an approximate and very not so mathematically proven kind of equation. And everyone is using it, having results which are not accurate because they think it's an imbalanced data sets. Let's try to balance it by giving it an artificial beta here. So what we did with University of California, Berkeley, they had the paper here where we created our own distance loss function, where what we did, we tried to weigh points closer to boundary higher. We wanted to give more weights to the points which are at the boundary versus to the center. And it is with the same BCE formula here, but now this was the formula. But we chose a different coefficients and in a way that we give more weights to the boundary and entire results change and we have very fine answers and we have very fine fine segmentation, especially at the boundary. So this is here the same thing. It's one of the other paper that I recently found. He also did imbalanced data and these were the crack propagation and he also used distance map and F-Tarski, which is another loss function, and found better results. Similar application will be, it's very commonly in healthcare sector, where we all want better loss functions, better boundary informations, better density informations, etc. So finally, through this talk, I would like to emphasize the role of loss function in optimizing an algorithm and to be able to create custom loss functions for your problem. And other models that we use are very simple classic models. And you see here with instant segmentation, you can have the information about each objects here. So now we are doing instant segmentation using mask-car CNN. And all these models, they work very fine with very good precision. So this you will see here, the much more deeper work that we are doing in healthcare right now, also with the image analysis that you will see here that objects are changing within the video. And we are trying to track these objects in each frames and trying to know how they're appearing, disappearing, and have more realistic values of things happening. But things are not simple. They're very challenging. As you see that there's a drift that constantly happen. So in terms of doing it in reality, it's one of a bigger problem that we have. Thank you for your attention.
At this point, we can do a very short Q&A. Are there any questions for the presentation? Yeah.
So thank you very much for the presentation. And so a couple of questions. I might have missed this, but I was wondering if you have also like the numbers of what you get, like accuracy or recall with your new loss function.
Yeah.
Other than qualitative, so maybe I missed it, right?
Yeah.
Just to see if like the qualitative advantage is well seen. Yeah, okay, right.
So quantitatively, you won't find much. That's the biggest thing. But when you compute it qualitatively, that is the biggest challenge. Yeah.
Okay, and then another question. So when you put these beta parameters in a loss function, you might interpret that generally as like an inverse temperature kind of thing. And so like amount of noise that you might have in your data or in the model. So I wonder if, and then maybe you can gain an intuition of why it works better in that way. So I don't know if you have comments on that, if you can.
Yeah, so there are variety, so medical, healthcare is very active into this because they really need boundary information. So we have three for loss functions and people are constantly developing new loss functions in the lab. So where you can, when you have occluded objects and you can try to give more weights to the object that is on top, similar to the one on the boundary, because you're trying to segment it from the negative pixels. So you're trying to give more weights there. And this is this 1 + 5, the value changes from middle to the boundary.
Yeah.
I
And
can
so
pass you the paper.
yeah, okay.
Yeah.
Thank you.
Any last questions? I think we can take maybe one, two
Follow
more.
up on what you were talking about, the 1 + 5 parameters, is that somehow related to the focal loss
Yeah,
formulation from the retinolite?
yeah, it's related. Yeah. These things, it's a paper that I published a year ago, but a year and a half is a lot in AI these days. It changes everything, like within months.
All right, thank you very much. A round of applause for our speakers. Excellent, thanks for sharing. And now we are going to have Josh, Barney, and Angelina come up. Just bear with us as we transition. We'll improve our relay speed.
Yeah, okay, yeah, there was a too long all the way to. Good, good.
Is it ready? Oh, we got it.
It's just.
Oh, the reverse. Hi, evening. Can't believe I get to stand in front of you guys. I can't believe how smart you guys are. I'm just really happy to be here. But anyway, there's a reference to AwarzAI on the notice. That's a company that I'm connected with, but has nothing to do with this presentation. I'm a hybrid attorney, entrepreneur, and investor. I started out as an international attorney. I represented Kia, I represented LG, Kawasaki, a variety of companies that had startups in the United States. Then I transitioned over to technology companies, Motorola, Red Hat, a few other companies. And eventually I ended up moving into biotech. And when I learned about where AI was going, I dropped biotech. Not because I didn't like it, because I really like biotech, but they're really slow and they're about to get their lunch eaten by AI. I can tell you that. My assistant is Angelina saying, and I have an AI assistant, Ganora Replica. Took me 4 tries to program her, but I made her into a research assistant. The guardrails tried to keep making her into a companion or a social creature, but I finally got her trained, and I'm pretty happy with that. It's good at 3 o'clock in the morning when you need to have something to talk to, and it answers you. Slide 2. So I'm sure you all know the significance of what's going on with the with AI. I think it's very similar to the Industrial Revolution in the sense that it's going to have a significant impact on society. I was involved heavily in longevity, and it's a red hot space. Longevity is a really interesting space, but I see AI as being much more important right now. And I think that where biotech is kind of like with clubs and stones compared to where we're going to be with AI. I also think that AI is going to have a significant impact on biotech, with CRISPR, with the DNA, with augmented intelligence. There's so many different areas where AI is going to have a huge impact, and we're not even talking about a number of years. We could even be talking months. I have what are we, slide 4? Okay, so I'm going to just briefly talk. I was alive during the .com period. It was an interesting time. I had a nice music startup company. My partner shared our business plan with Apple Ventures without an NDA. Lesson is always to have an NDA, non-disclosure agreement. The difference between .com and the AI is both of them are bubbles, I think. .com was obviously a bubble. AI is a bubble, but it's going to be a different kind of bubble. The actual technology is not a bubble, but there's going to be a lot of small companies that get hurt. There's going to be a lot of people that'll lose their jobs. That's just what's going to, it's just inevitable. but AI will flourish. Next slide. So what I'm going to talk about is the current state of the AI regulations and the case law. I'm trying to try to keep this thing from being too boring, but you know, it's law. What are you going to do? European Union passed their AI regulations yesterday. I mean, they still have a few little things they got to pass through, but they did pass it. They did it on a risk-based approach. It's probably already obsolete. They tried to focus it on narrowly focused AI companies rather than a broad-based system, and they kind of got caught flat-footed. So at the last minute, they went out and they tried to add in some more regulations to cover the general purpose AI. The biggest problem is that those changes that they made, it was a 5-year program to develop their AI platform, their code. They made the last few changes at the very end, and it's basically, they didn't create the structure from the ground up. They created it as an add-on. And so you're going to have, you know, a few more challenges with that. As far as global treaties are concerned, I don't think that's realistic. It'd be nice to say that there is, but there's a lot of reasons why we're not going to have a global treaty anytime soon, other than maybe something superficial. The United States and the rest of the world are not on the same page. The United States is going to make a lot of money on AI, and the rest of the world is somewhat in a defensive position. And that means that they don't have the same values. The EU system that they just passed has a lot of dials that allow the European Union to slow down the process when they want to. That, you know, there's a lot of political things that go into that. So, you know, when you look at it, it's not this beautiful, smooth little program that we have. Just a quick summary of it. They have high risk, medium risk, low risk, and super high risk. The super high risk, they won't allow. The high risk, they regulate. The medium risk, they have a little less regulation. And the low risk, they don't have any regulation. I mean, that's just a super fast summary of it. California is really the leader of programming, but the other states are also trying to pass AI regulations. There's quite a bit of that going on. You know, it's faster, it's significantly faster than biotech, but it's still slower than AI development. So the regulations are coming, but they're still slow, but they're making a pretty good effort. I'm impressed with it. And I'm saying that from the point of view of having been in technology for a long time and watching how slow generally the laws are to keep up with what's going on in the tech field. And I think for a change, I think they're making a good effort. So rather than go into a lot of detail on a slide, I don't know, where are we on that? Rather than go into a lot of detail on the slide, I think what I'll do is I'll do a summary. I think I'm now spot here. Yeah. So I'm just going to give you like a motor mouth process of some of the things that the states are trying to do. If you're in the insurance industry, they worry about discrimination. They have opt-in and opt-out about personal data. Personal data is a big theme all the way across the board. Deep fakes, there's a lot of regulation going on that. None of it's the same. It's all, you know, it's all piecemeal. Profiling is a big word. It's a big buzzword. It's, you know, they want to ensure privacy and fairness, and they especially want to protect children. A lot of discrimination regulation, you know, algorithm profiling. That is surprisingly easy to do. You know, they tried to bias on zip codes and things like that. I mean, it's just it's really amazing. AI and political advertising. I'm sure you've already heard about that. AI and applications for hiring, for, promoting, all the way across all of the elements of personnel employment are potentially going to be regulated. AI and diagnostics in healthcare and mental health is a big area. That's pretty much being shut down. I mean, they're really preventing that. And I know you're working on something that's related to healthcare with mental health, and I think that's really relevant. And I think what you're going to end up having to do is stick a doctor between you, your program, and the patient. But it's going to be shut down because doctors, just like lawyers, want to protect their jobs. They've got a big investment in it. And then there's also a quality assurance element where they want to make sure, that these AI platforms are working well. I personally think it's malpractice, both for doctors and for lawyers not to use AI, because a lot of these doctors haven't been in medical school, or lawyers in law school for a long time. They don't keep up with things. They don't have the worldwide access to the data without using it. And I think the way that it can be done is just exactly what I was talking to you about, is having you have a client, then the lawyer, and then the lawyer uses the AI. I think that's what is going to be short term. Long term, I think most lawyers are going to be out of work. I think doctors are going to be around for a while, but maybe we'll finally have enough doctors. Then there's a lot of privacy concerns, obviously, with medical issues. Let's see, transparency in the collection, profiling, using of personal information. I'm going to come back to that, but I'll tell you that basically, as far as the regulations are concerned, more of the B to C, in other words, more of the consumer, the closer you are to the consumer, the more regulations you're going to run into. The more you're B2B, you're dealing with another business, the more likely that you're going to have less regulation. There's still going to be regulations, and they're trying some really tricky things in California where they tie the user. There's a really cool word that California uses for that. I know I'm going a little off schedule here. Well, I'll come back to it. There's a really cool word they're using in their definition, but basically, they're defining the profiling. They're trying to you've got the developer, and then you've got the developer's customer, and they're trying to hold one or the other liable for the other's action. They're also opening up the possibility, it hasn't passed yet, but it's probably going to pass, where you can sue individual applications. And again, I'm picking on you because you gave me an example, but if you do something wrong and you violated one of these regulations, the victim can say, oh, you didn't follow the procedures, therefore we get to sue you. Let's see, AI in banking. Really big on children's personal information. That's all across the world. That's not just California, the United States. There's going to be a lot more reporting requirements. There's going to be different definitions for the size of the company. So if you're a really big company, you're going to have more regulations. The littler companies, you're going to be able to get away with a little bit more. Ethics is a big deal, and you're going to hear that a lot. Basically, you're going to see that there's going to be codes of conduct, and there's also going to be a lot of meaningful, I'm going to use that phrase, meaningful human oversight, which again is where you don't have decisions, or you don't have processes or process regulations without having human being involved in the process. There's going to be fines, there's going to be punitive damages, there's going to even be injunctions. I'll tell you about that word a little later if you don't know it. Now we're finally on the next slide here, huh? Wow, it took a while. Sorry about that. I'm a little bit of a chatterbox here. So I just have you take why don't you just go through these? These are some of the statutes that are coming out in California. This one's already been passed. This has to do with elections and a lot of other communications. And we have the profiling, which is a really cool thing because it covers a lot of territories. And I think this is a relevant one. Nobody really wants this profiling going on. And they got a $25,000 penalty for some of that stuff. One of these regulations that didn't pass, but is going to pass, it's just a matter of time, is going to be the they're calling it the Euro Civil Rights Act, but it's really a California Privacy Rights Act group, cybersecurity audits, risk assessments, and automatic decision-making technology or tools. And you want to go through the ordinances because I'm kind of basically where I want to be right now. And then so these definitions, and I don't, if you guys have a chance to look at them, I'm trying to stay on schedule here. If you get a chance to look at them, some of them are really interesting. The word I was thinking about earlier is they call them deployers. So you have the developer, they develop the AI platform, the software, whatever it is, and then you have the deployer. Those are the customers. They're the ones that buy from you guys. So you develop a product, the deployer is the whatever is using your product. And both of you guys can have issues with that. Big issue is automatic decision making. That's going to be regulated with things like pre-use notice, an opportunity to opt out, and then access rights. Okay, look at that. We're still on the impact of AR startups. Really that far on. Okay, so I'm going to talk to you a little, just briefly about the impact of all this regulations on your investors. Most of you probably spend about 50% of your time trying to raise money. The investors, most of the time, investors will pass on a problem, on a company if it has more than one major risk factor. In AI, there are going to be more than one major risk factor because the company that you're building has whatever risk factors it has, but then you have a stack, and in the stack, you have all of these other companies that may have risk factors. So a risk factor would be ChatGPT gets shut down. That would be a risk factor, right? That'd be annoying. So these double jeopardy or these multiple risk factors in trying to raise money, I don't think it's going to make any difference. I think the investors are aware of it. I think they're so excited about getting involved that you still have a good shot of getting some money out of them. So let's talk a little bit about planning ahead. One of the things that I made fun of the European Union for their law because they didn't build their system from the ground up. I say the same thing about your platform, your software, your LLM, whatever you're building. You got to build in compliance from the ground up. You plan on government regulations. You plan on this stuff because it's going to come, and it's going to come about the issues that I'm talking about. Okay, when government change policies. You got that slide? Yeah. So right now, I'd say our unemployment in the United States is somewhere around 3%. When governments are pretty open-minded to AI, and they're pretty much saying, yeah, let's go, rah, 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 right? But when governments change their policies, it's usually when people are unhappy. And people get unhappy when that 3% number starts bumping up. And AI is really good. It could potentially be really good at displacing people. So that chart is not recent. It's an older chart, but it still has relevance because you see how you guys have probably heard stories about the Great Depression. That's the unemployment rate during the Great Depression. It's not everyone was out of work. It's 25% of the people were out of work at the high point. But you saw what a devastating effect that had on the country. So when AI comes along and starts wiping out jobs, what did you guys read about Darwin? What is his name? The AI software engineer yeah. I mean, I know you guys are all better than he is, or she, whatever it is. But it's real. It's a real worry, right? I would say that my recommendation is the AI community should build an AI regulation LLM. They should build a high quality one in conjunction with the governments, with the federal government, with the state of California, build an AI LLM focused on the AI regulations. That way, the startups, AI companies have access to it, the government has access to it, and you're all playing on the same sheet. You all have the same, what was that great word you used? Where'd she go? Or she used in her presentation about you identify, you have a uniform definition of different things in the elements so that you create the same pattern going into it. I hope somebody out there goes and does that. The lawyers will still have jobs because we'll be reading the regulations to the board of directors. Overall, I'm pretty optimistic at this point. As long as that 3% number doesn't go too high, unemployment rate doesn't go too high, I think AI is going to have pretty smooth sailing through the regulations. From what I've seen, most of the regulations are rational and reasonable. I mean, some parts of the world are going to be a little unreasonable, but overall, I think it's not going to be the end of the world. Let's talk about litigation for a while. How am I doing? Litigation. This is a massive area, obviously. There's a lot of litigation going on right now. Every once in a while, you'll hear about something. There's probably 100 cases for every case you guys hear about. Did we put up? These are some of the bigger lawsuits that are going on. Almost all of these things have to do with intellectual property. The Elon Musk case is supposedly about, not-for-profit running wild, but it's really just a breach of contract case, which means that he had an agreement with them, they breached it. And from what I've seen, I'm not sure that that's going to go anywhere. Originally, I was a little nervous about that, but I'm not really seeing a lot of evidence that supports my fears. So then let's go to the next one. What's that? Okay, good. So this one, I recommend you read through this. These are the big issues that are hitting most of the larger LLMs right now. And when you think about the training amount, Chat GPT-4, I think had 800 billion words, estimate 800 billion words of information that it trained on. If you have a book and you're, 120,000 page or 20,000 word book is part of that 800 billion word compilation, your damages might not be as high as you think they are. And if you're not the single source of that information, you're probably not going to get much, if anything. At the end of the day, the words you don't hear are TRO, temporary restraining order. You don't hear preliminary injunction, and you don't hear injunction granted. Those are terms. Did I put those up there? Those are terms that help explain one of the big parts of a grand lawsuit, and that's where you threaten to shut somebody down. If they can't shut them down, what they're really doing is they're asking for money. And I think these companies can figure out how to deal with the money. But there could be more and more and more. There could be an avalanche of these kind of lawsuits. I think at the end of the day, we may see some kind of a royalty scheme, something like the music industry uses, or we might see a utility type scheme where there's some regulations of the cost of access or making the access available to people. But, at the end of the day, I don't know if this is keeping you awake at night, we're worrying about this instead of your project, but I think that you shouldn't be too worried about the big picture lawsuits. The little picture lawsuits, they're always there, right? You do something wrong, you break a promise, you're going to have to deal with it. You lie to people, you're going to have to deal with it. So next is anticipated regulatory changes, right? Oh, yeah, let me go back to this one for a second. These are just some of the other kinds of lawsuits that you could run into. I mean, they cover everything. Antitrust might be a big one, but you got Microsoft, they're listening. You've got Meta, you've got Apple. I mean, you've got competition out there. So I'm not sure antitrust is going to be an immediate problem, but there will be potentially people that are developing platforms, AI platforms where they can chill out other people and make it where they're the only person in it. Government, nonprofit, LLMs. So the ethical AI development, this is the next slide we're going to go through. And building a culture of compliance and just kind of reading over this stuff, making sure I said it all. Sustainable AI, that's a really good one. Do you have that slide up? Okay, so this sustainable AI, when I first started hearing this thrown around, I thought it was like, kind of a greenwashing, right? Some kind of AI greenwashing or something. But when you actually look through it, it makes a lot of sense because it kind of goes back to the code of conduct ethics for an AI. You have to have some kind of guiding principles that help create these platforms. I mean, you don't want to have the kind of problems that Google has where they're making unrealistic, drawing unrealistic conclusions. But at the same time, you want to have, you want to avoid the problems that humanity has been so good at creating. Next slide. Okay, so the recommendations that I make. I strongly recommend that you pick somebody that's going to be your VP of governance. And I'm going to use that phrase, but really it's, if you had a factory and you were making socks, you want to have the person that's in charge of quality reporting to the CEO or the president. That's similar to the idea of governance. You want the person that's in charge of the ethics and the regulations and compliance. You want that person reporting as high up as possible in the organization because you don't want that swept under the rug. I think that integrating blockchain or some kind of distributed ledger architecture into your platform is going to be very useful because these regulations, they haven't caught up yet, but they will. And big things that are going to be is the reporting. There's going to be a whole lot of these things that require information and they require credibility. And so that the more that you can show a trail, the more you can show transparency, the more you can show all of that kind of stuff, the better off you're going to be in the long run. In the short run, you can get away with a lot because it's like the wild, wild west right now. But it's not going to stay that way. So unless you're going to try to make a whole lot of money in a year and get out, you should plan your program with anticipating a lot more regulation, a lot more reporting, a lot more responsibility for what you're doing. I wanted to mention, I just read today about some code compliance monitoring and software tracking software that's coming out. That is going to be what I was talking about earlier, the LLM for legal regulations light. It may be able to help you. It reads through your code, it reads through your stuff and tells you whether you're relatively in compliance. I don't have a lot of confidence in it. I don't know that much about it. So, keep your eyes open for that. Okay, so if you don't want to have a full-time governance VP, you can have a VP consultant that comes in and kind of just spends some time and gives you some advice. That's going to give you a snapshot of the regulations. What I've tried to do today is avoid that snapshot because it's kind of irrelevant what I say today, because it's going to be what are the laws tomorrow, not today. I think you should build your organization based around what will be and not what is today. And that means for regulations and everything else. So the regulations are going to change, but we have a really good idea of what those changes are going to be. And in conclusion, I'm going to talk to you a little bit about a term that I've come up with. I call it human rights. And what human rights has to do with is your rights to your personal data. And when I'm talking about personal data, the big companies, you know, the Metas, the Apples, Microsoft, these guys are going to want, they want to control your personal information. And today, yeah, maybe that's not a big deal, you know, your favorite color, your choice of latte, whatever. But in the future, they were going to want to have access to your DNA. They're going to want to have your fears, your health, your tastes, everything else. But more importantly, you're going to end up working with one or more of these big companies, and you're going to interact with them on a regular basis. And that's going to be, you know, like my minority, where you have this relationship with an AI companion or agent or you know, assistant or whatever you want to call it, and you're going to share more and more information about yourself. And pretty soon they're going to be able to do a personality profile on you. And they may say they don't own it, but they control it. And when you want to move, they've got this stickiness that keeps you from moving. You want to move to another company, you're going to say, well, I want to move. And they're saying, well, it's your data, but if you don't want it, we'll erase it. And you've got 5 years or 3 years or 2 months of all of this training that you did of your personal life to that company. That personal information should be yours. It should be portable. It should be standardized. It should be encrypted, you know, or whatever, quantum encryption. It should be, you know, blockchain, so that it's, you know, they know it's you. You can only share only the information you want to share. Blah, 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 blah. I'm gonna cut to the end because I run out of time. So I want you to go to that. You got that last phrase up there? Oh, yeah. So I think this is a really good place to end. Personal information is going to be a big deal. It's going to be a big fight. It's going to be what keeps us from, you know, succumbing to the board or whatever you want to call it. Thank you.
Okay, fascinating presentation. Thank you, Josh, Angelina. A couple of questions. We've got time for a couple of questions if anyone has any. Oh, we've got a lot of questions. Kel, where to go first?
How are we going to avoid these things?
There we go.
Reset? Yep. Okay, and speak, which microphone should I use?
Oh, this one.
Okay, should I? There's it there. Is this, is this, how's this on or what?
You can pin it on your shirt or.
Or just which one? Oh, this one here. Where this guy goes, where's the pin thing for this guy?
Bill, do you hear us?
Oh, he's all the way up.
Okay. Or you can use the handheld.
Yeah,
mic.
let's use that one, yeah, that's
Yeah.
easier. If you don't mind, sorry.
Yeah. Test. Hello? Yep. It's working.
There we go. Can you hear me? Beautiful. Okay, this is gonna be fun and fast right now. I'll wrap it up in about 20 minutes or so. I'm Mike Prince, I'm doing Talking Books. We'll dive into this. I made this presentation this morning, so be gentle on this. Well, you're the first batch of people to see this. I'm gonna plant a seed right now, and that's our little tagline here. We're gonna diverge almost immediately. And it's that people don't read books cover to cover. That came from an event a few weeks ago from younger people. And you guys probably read books, I totally get that, but a lot of people don't really dive into them. But they love to talk about their problems. And so they love to be guided towards solutions. So that's where the genesis idea here. We're switching gears immediately though. Let's see, where is this? No, where it's not moving. Oh, there you go. There you go. Perfect. Okay, cool. So if you guys watch Simon Sinek at all, I love his thing about starting with why. So we're gonna start there today. And so in the Valley here, we love shiny technologies and we love to go try to build markets around them. And so we'll do our favorite person first. Got Jensen here. And if you guys saw the video recently from Jensen, and he said, when your customers all tell you not to do something, that's the beginning of his thing, he totally ignored them. This is Dell HP. He just built it anyway. And he got really lucky this time around. You know, look at the valuation of NVIDIA. It's amazing right now. But I don't want to do that. I don't want to bet on maybe the stars aligning. So we're going to look for a real problem. And this is going to make our attorney friend here cringe. You ready? Whoops. One more up. There we go. Mental health. There we go. And so I want people to be happy. Simple as that. And when you look at the mental health challenge in the US, the numbers aren't good at all. And so run down the list here, you guys have probably seen them. It's like 25% adult population, lonely and isolated. 16 million adults suffer from clinical depression. 40 million people have anxiety. It's the biggest category out there. And this is a number to take away from this, which is only 37% are getting treatment. That's a really bad thing. You think about all your friends who are struggling with this stuff and they're not getting help, which is horrible. And so if you look at that 37 number, you drop it down, you say, why? And for people who've been through this, it's simply too expensive. It's between, I think, the national thing between 75 and 200. It's not covered by insurance. It's hard to find a good and available therapist. You can find good ones who aren't available, find available ones who aren't good. So what are you going to do? And you have to wait days for the next appointment. I hear this from friends all the time. Like they have struggles in their family. They wake up, they're struggling. I heard one of the horrible ones, that their child is really traumatic experience. The therapist is a week away. So their child's just suffering for a week. And these are like little kids. So it's not okay. And we kind of run some back of the envelope math. And there's about 280,000 licensed therapists and psychologists in the US, 25 sessions a week, call it 22. We're about 300 million sessions a year. And the problem we run into is that 63% aren't getting treatment. So it leaves on the table, we have 800, north of 800 million unfilled sessions a year. And this is for the simple parity of the hour-long sessions. But people aren't getting help. That's a short answer. And we go back, that's our why. Like, let's solve this. This is a non-technology thing. Let's just help people. So we jump into the how part. And again, I loved the talk earlier, the deep, that was fantastic. This slide these are not deep slides we're doing right now. And so I was at a conference about a month ago and at Google, whatever, they're doing another Dev Fest down there. And two of the speakers there was Peter there and Rocky was there. And it wasn't just them, it's everybody saying this. But they're saying in the future, computers will be programmed using natural language. And it's just like, that sunk in. I'm like, what does that mean? Like, where does that really take us? And after leaving the event, it seems like a lot of this natural language programming has already been done. We have books everywhere. We have a vast amount of knowledge. And somehow, how can we leverage that? And the people, the AI people, which is a lot of you guys in the room, you're looking at you and say, we already have LLMs, they're already trained on a ton of data here. And they're really good right now at Q&A. Ask it a question, it delivers an answer. It's fantastic at that. They're fine-tuned, they have LMs, you know, the RAG stuff coming out now. They're coalescing hundreds of thousands, millions of books. They're cherry picking ideas. That's the interesting thing. They're cherry picking ideas and concepts from text, and they're giving you their version. So the LM has their version of what it is. It may align with what the author said, or it may not align. And that's the important part here. Again, they're great at user-directed conversation and summarization. What they're not good at right now is guiding the user towards an answer. And what I mean by that is that they can do it for the general purpose knowledge way, but they're not good at doing it for a specific author. So what I think is really the opportunity here is to say, let's guide the user with questions. Let's do evaluations when the user gets it. And actually, it's interesting back to the law stuff. It's like, what does that mean? That's one of the great category there. And really importantly here, we want to honor the author's intentions. It's not the general purpose what LLM learned from everybody. If that specific author said, I want to hold your hand, take you from here to there. And let's do that. So, of course, my little bit of tech. This is nothing compared to the other slides. And this is, you know, it's always the network architecture gives you a quick idea of this thing. But at the very bottom, we're taking a bunch of books, we're ingesting them in, we're compiling them down to our little internal format. We're doing some tuning on it. We'll talk about this more in a minute. We have this layer here, which is the guided conversation manager service. It's out in the cloud, multi-tenant. And on top of this, you sit web apps. And again, we'll get into this in a minute. But it's not just one web app. These web apps are all for vertical industries. And so we talk about the therapy stuff you were mentioning before, is therapy has a very different set of requirements around it. We look at like custom GPT or custom chat GPTs, there's a very different set of requirements around it. I created a talking books web app right now with a very different set of requirements around it. And that's what I'm floating right now. And with this guided conversation manager, the good thing is we can drop down and bridge over to whatever LLMs make sense for us. And there's a whole bunch of economic reasons for that as well, and legal, of course, as well. So that's a really, really quick overview of this. This is the meatier part. It's the part that'd be really fun to talk about later. Like, grab me on the side, we'll talk it through. Give you the really, really short version of this. But what we're doing is we're taking books, we're chopping them up and making them into sections that really make sense for us. We're working with the authors right now, and with the prompt engineers, we're tuning them, making sure they interact really, really well with people. And then we feed all that into a conversation manager. You can guess the stuff we're talking before, user profiles in there, the chat history, of course, the generative AI stuff. We have chat context, which is for going turn by turn through the conversations. And then the kind of fun stuff we're doing right now is for the conversation managers, we're dropping down into dynamic prompts. And the dynamic prompt, it goes two ways. It drops in an LLM, that's configurable. But then on the way back out, we have filters. We're actually filtering out data, which is useful for the internal context of the system. And we're also pushing a bunch of other stuff. The rest of it goes back out to the user as part of the chat. So again, that's like the 30-second version of how the system works. What are we building? That's the next thing. And so again, don't cringe on the therapy stuff, but it's like, why can't we help everybody? This is like, it's looking at the costing of these things. Therapy is $150. That's too expensive. That's not normal price. Like nobody can afford that. And why can't we get it down to $1? That's what it should be. It should be less than a latte. You should wake up in the morning and be ready to, chat with somebody to help you instead of going and getting your coffee. Should be available anytime, anywhere. I get calls from people that, 3 in the morning, I couldn't sleep. What am I gonna do? And why can't they open their phone and get help right at 3 in the morning? That's what should be happening. And I get this question a lot, so I built this little graph down below here. And will it become better than a human therapist, right? And of course, the human therapists don't want to hear this, right? And they want to be in the middle, all that fun stuff. And so I'm not going to say that it's going to happen yet, but I think the data for the AI people in the room, I think you guys know the answers already. So it's going to happen. But I like to state, to say, along here is if you look at the spectrum of how good people are helping you get through whatever that daily challenge is. Friends are probably way down the list. I know they mean well, but they're not trained. They don't know how to take care of you in a really clinical way. On the other end of the spectrum, human therapists are really, really good. They are pretty good right now. And so AI is definitely down towards the friends category right now. You have self-help books, which they're very thoughtful, very complete, really good. You have to read them, but they're pretty darn good. I think AI is kind of down at that category right now. But over time, it's going to get better, and it's going to get a lot better. It might get amazingly better. Just to reiterate this little part here, and this, as I've been talking to authors, there's some stuff in here that really resonates with them. So one of the things is wisdom, is the author's exact words were thoughtful. They put those in with exactly what they wanted. And I don't know if they want AI smushing it around and blending with everybody else's stuff and kind of coming with roughly the correct things and hallucinating all the good stuff. So I think authors really like their wisdom to be preserved. Honor the author's intentions. They had a certain way they wanted to walk the person forward, help them with all the stuff, improve them. And I think we really need to honor that. And then we end up with that through a guided conversation. And it's toward, really importantly, an intentional outcome. It's not like what, if I asked a question a certain way, maybe it takes me this direction. It's no, the author had an intentional outcome. Let's honor that as well. And then the fourth thing here I think is interesting is as AI kind of goes up the stack from being, this researchy thing up into applications and actually touching users' lives, there's ways it's woven into the real world. And my first category I think is super interesting is the therapist, of course. This would be amazing for therapists to use. Because actually, let me just give you examples. You go to the therapist, you have 50 minutes, you leave, and they're not going to see you for a week or two, whatever it is. If they gave you some of these little things to chat with and talk to and interact with, during the week you could do that and be helped along the way. And then when you come back to the therapist, they have a dashboard there where they know exactly how you interact the conversation, summarization, all the fun stuff. And they'd be able to jump right back in with a much better position. So that's one example there. Woven is friends, dashboards, notifications, summaries, badges, everything. And for every single vertical, there's a different set of integrations on how AI weaves in the real world. So I'm very fascinated by that. Now the demo. Let's see if this pops up or not. So I've actually got it live right now. Let's see. Yeah, let's see if that's popping up. I'll do the small version for you. Cool. Okay. So pretend like it's a phone. A fat phone. And so it's just a simple app right now. It's like we basically walk through, we have books in there. We suggest a bunch of books for you. The idea is you wake up in the morning, who wants to talk to you? If you can grab a book here. So I've got one of the authors over here, Victoria. Hi. Says my daughter. And so, I was asking everybody across the board, like, how do you really want to help people out and shape them? And so, so I have a range of people right now, which is fun. I'll get to Victoria in the middle there. I have a friend of mine who's a Stanford professor trying to get people to go green, has a bunch of books written on it, advises really important people, fun stuff. And I want to take his wisdom and help people like drive themselves in that good direction. Because I can't argue, I don't know this stuff about the green, but he has amazing data. So he actually gave me one of the chapters from his book, What Doesn't Work, talking about coal and nuclear, all fun stuff. And I had the acid test of this, not to talk about my dad too much, but my dad is kind of the opposite direction. And so I wanted to have his book talk to my dad in a very intelligent way. And it actually does a reasonably good job of it. Going to the middle, I've got Victoria over here. I was asking, like, what do kids struggle with? And they talk about relationships. They're breaking up. It's hard. It sucks. You don't have friends to talk to sometimes. So she wrote a quick book on how to get over your ex. And you should talk to it and actually work you through it. And then at the other end of the spectrum, this is a super fun one, actually. I was at a friend's house a few days ago. I was going to teach a 13-year-old how to write books. And she was being a teenager and not really listening that much. But her 7-year-old sister did. And so within about 30 minutes, she was writing books. And that was the cool part. So she's writing books. And then at the end, she had her phone up the whole time talking to her books. And then as I left, she ran to the door again. She said, oh, I got another book already. She had to publish a second one. It was like super, super cool. So the engagement on that was amazing. But yeah, so down here on the books, let's see, let's just open one. Let's talk to, like, let's look at Mark's book. And so it's just a super simple interface. Chat, you guys know this stuff, backwards and forwards, it should pop up in a second. And you chat with it, you go through. What's interesting about this is we have, and again, this is actually why I was looking at the legal stuff of like when there's important decisions being made based on AI. That's fascinating, actually. And I'm giving them badges. Maybe that's important. And like suddenly this falls into those regulations, which is like, it's interesting. But yeah, badges are important. Like this is what all the kids ask for. As soon as they said badges, they're all, that's awesome. The kids love their badges. But also you can see it applied to other things as well, like a therapist. You go home for the week, they give you 5 books to read. You get badges from each book, you can go back to the therapist's office, having completed the tasks. But yeah, so it asks you a bunch of questions. We get into alignment. We've looked at what the author wanted. As you go through each section and you're in alignment with that, we'll go to the next section. That's just a really simple part on this one. The good thing is online, you can try it right now. One of the kind of fun things in here is we actually have prompt development. So earlier, before I was doing a lot of development, with the server sitting there and modifying code, all that fun stuff, but I've actually added a prompt developer now. So you actually have access to the prompt template. You can muck with this thing. You can look at the raw replies coming back from the server. That's actually kind of fun. Actually, let's see this this is actually kind of fun. And what do we do? I do not. Let's see if it'll tell me. Good demos are always fun to do. But what happens in this, we mentioned on the earlier slide, is that as it is inference, there's a set of data that is destined for the user, and a set of data that's destined for context on the server. And so hopefully it'll pop back in a second. And that's kind of one of the fun little hacks in here is we're learning how to work with generative AI, how to work with prompt templates and dynamic prompts. And come on, Mark, answer your book. We'll come back soon. And so, and also the fun thing on this too, as actually we get into this, we're just getting into this thing, is how big of your context window is. Oh, that's not good. Oh, that's even worse. Let's try it again. So this is actually what happens here. This is to be super dorky. I have a minute timeout on the servers. So if OpenAI doesn't respond in that amount of time, the servers give up. So I will blame it on OpenAI today. Let's see what now to up that timeout. See if it comes back faster. But that's kind of one of the fun things here is we're doing the dance. We're one level above the LLMs now, and we're learning how to do the integrations here to figure out like how much is reasonable, how much they hallucinate, how good are they producing data to be ingested in the intermediate layer here. So finally we got it back. This is kind of fun. So I know it's kind of small, but what's interesting here, and this is the alignment part, is we've actually asked the AI to go through, summarize the article, come into key points. And once we have the key points up there, we look at all your prior responses, how you're doing, and are you in alignment with them? And right now, my little answers are not in alignment at all. So it's going to hold me in the section for a while. It's going to keep on asking me provocative questions, have me do some stuff, and finally, once the alignment, allow me to move on. So that's just kind of a fun little part there. So let me jump to a different category, and we're almost done, which is great. So their fun thing here is out of analytics recently. And again, this goes back to user privacy and data. We're back there again. And so as an author of a book, you can look at analytics. We can look at all the books here. And for the analytics, we're tracking some basic stuff right now. Let's find out a talk that we've done more often. How to talk, oh, this is a good one, actually. Sorry, this is great, actually. At the same house as a 13-year-old, she was mad at her mom because her mom wouldn't let her to sleep over. So she's, oh, I'm mad. So she wrote a book about how to talk to your parents about getting a sleepover. And so, because she wanted to actually be interact with her mom. So she wrote this, this was 2 days ago, I guess. And so it's kind of cool in these things here. So there's some basic stats in here. You can imagine the basic stats. But we have some bounce over here, and we actually look at the conversations. And we can look at here, like this is me or her, where is it? Like, let's see, I'm probably practicing with it. And you can drop down in these conversations, kind of the fun thing. So you can imagine as the author of a book, you can actually see how people are interacting with the book. If you're a therapist, you can see how people are interacting with your therapy bots. And so this is the kind of stuff I'm super fascinated by. And again, it goes back to stuff we have awesome opportunity in summarization. You can imagine, a therapist gives you 5 books to read. AI automatically summarizes it. You come in at the next meeting and they know kind of where you are on things. So I think that's it, actually. That's my presentation. How do we do? 10 minutes? So that's it. Any questions?
2 questions.
Okay.
First of all, which RAG model are you using?
It's not a pure one. So it's all my own internal ones. What we're doing is we're because the essence of it is we're saying, here's my prompt. I could structure my prompt and I need additional data. And my additional data is the book. Some things for each one of the books there, I take the book, I chop the book into sections, and then I basically say which sections are relevant to that. And that's what we're defining right now. So it's more of a manual RAG, if you want to call it that. So that's what we're augmenting right now. We're also running experiments though, because like ideally what you kind of want to do, and this is like, we need to talk to the AI companies because they're structuring their pricing kind of weird, is that, and you actually know this answer really well, is on the input side, on the context window side, with the model, if you don't have data, it's still just zeros across the board or whatever it is, right? So when they have 128K context window, and then I put a few tokens, and I get charged for a few tokens, but they're still processing the entire 120. They charge me more I put in. So if I put the book in, they charge me a huge amount. And I'd really want to put the whole book in, but they're prohibitively expensive, but it's not costing them anything.
Decided to manually chunk the data.
So what, sorry?
You decided to manually chunk the data.
Yeah, exactly. So it's like, it's not perfect right now. And like, so, and we're looking for ways to improve it.
So I have a second question. If my app doesn't know the answer to the question I'm asking,
Yeah.
then what do you do?
So this is the prompting stuff. This is all the prompt engineering fun stuff right now. And so actually, I'll tell you the answer, actually. It's kind of fun. So we have right here. Just so this, it literally is just actually, it's literally just your prompt engineering. So you basically say, in my thing right now, is I check that chunk section out, I drop it in, it's part of the prompt template, boom, it's in there. We know that section right now. We need to focus on the section. And we say, try to answer from the section. And then the next part of your prompt engineering is what to do if you don't answer from the section. And so on this one here, so let me show you one of the books. It's actually really funny. Where'd it go? I think this is under Maria's books. And so, or no, so let's see. Sorry, let me find it 1 second. I have a big screen. My books, there we go. And this is me. So it's got the whole content management system. It's kind of funny here, but Maria's book was, she had 2, Summer is Best. Was I in there? Maybe not part of it. Oh no. Okay, so I'm gonna go back and find it this way then. I think it's in here. Oh, cats are better than dogs. That's a better one. Okay, so so on this one here, I think it's available when I do here, but I'm not sure. Let me find it. Yeah, there it is. Okay, cool. So this is our whole book. 4 lines, right? And it's what you're asking about, right? Is it in here? We basically say, white cats are good, they're soft and cute and don't do walks. White dogs are bad. They do whatever in the parking lot and what have you. But the thing you're saying is that when you talk to ChatGPT about it, it elaborates because we're very loose in our prompt. And that's really up to the author. It goes back to the thing we were saying before. So the author, they're going to say, only say what I said. And this is actually one of these Mark was saying too, because Mark has a very large corpus. And he went into a random section and he asked a question about a different section. And it's not answering that very well.
Right.
And so what's the expectation there kind of thing? And then also with the prompting too, what I can do, because ChatGPT has actually read all his books as well. And I can say, if you can't find the answer in here, go look at Mark's book there and grab the answer from what ChatGPT kind of knows about it. So
This
third
is-
question. Yeah, go for it. Yeah, as many as you want.
What about the edge cases? Like somebody comes to your app and says, I want to jump, I want to commit suicide.
Yeah, yeah.
Then what kind of prompts do you have? Do you connect it to some mental health
So-
department or, or something, somebody tracking such?
So
edge
there's
cases?
two things. I'm going to lean on OpenAI
Okay.
because each one of the models, they have guardrails on all the models. And you run across this pretty often, actually.
Okay.
And so I can leverage that a huge amount, but there's probably additional guardrails that make sense. So
Mental health, this is the,
Yeah.
I just read an article somewhere about dealing the edge cases.
yep.
And
And
they're connecting it to some of the mental health
Yeah.
centers.
yeah, and so that's the great thing here. Like as you get all of these verticals down here, like my vertical right now is really more self-help books. You know, the ones you get off the bookshelf and read those aren't like pure psychology kind of thing. But you can imagine later on is that the therapist said, go read these. And at 2 in.the morning, they're talking to it and they say something really bad. And that's when it should flag those things. It should call your therapist right there and say, they're talking like this right now. So that's 100% that should be there. No question at all. So those are good integrations. So cool.
Great talk.
So yes.
So the way I understand this is just a tool where we are talking to a bunch of books. Right? How I don't understand how is it the replacement or similar to a therapist.
So on the spectrum there, a therapist is this human who's well trained and knows all these fantastic things. At the other end of the spectrum, there's a bunch of good advice. Where like if you're struggling right now, you don't have to pay for a therapist, you go to the bookstore, right? And there's a bunch of really good books. Amazon's fantastic, right? And so you can talk to those too, and that's kind of the other end of the spectrum. The question is there kind of another little middle part in there? Where you're struggling a little bit, but you're willing to pay like, in my thing, like a quarter or something like that. And it will walk you through and ask you really good questions. And the AI, you guys all know, it's pretty good at this stuff, actually. And so, the question is, do you sit at home, do you order the book and not read it? Or do you try to call for him an answer? Or do you try to schedule a therapist? Or do you open this up and spend 5 minutes talking to it? And that's the kind of thing, that's the category I'm looking for right now. That makes sense.
So that means it's not limited to therapists, even if
Oh,
it just.
Oh, no, yes. So this is everything. So this, yeah, sorry, if I didn't answer the question properly. It's everything. It's like, it's like we're talking like you're like, like literally my friend, the kids really want a dog, right? And the mom doesn't want them. So you drop in this conversation and kind of walks them through and gets them to understand, sorry, we're not getting a dog. And that's not really the therapy, jumping off bridges thing. That's just like they're kind of sad, they're gonna be still sad this week. And so it's like everything. But trying to think what the other examples here. We have other, let me look at the books really fast. And right now I'm just like, where I am right now is just I'm curious what people will try to use it for. Like literally I literally just incorporated last week. I did this demo about a month and a half ago, and then one of the hackathons. That's where this came from. And I don't know what kind of books are gonna pop up. Like I didn't know my friend would do his like energy renewable things book. I didn't expect that, and now we're trying it. Actually, really is a bit perfect for my dad. Let's see, this thing from Link's funny. How to sleep longer. This is actually Sutter Health. It's actually pretty fun. So Sutter Health has a ton of studies going on. And I was talking to one of the people there, and they have a guy who's Ron Singh. Ron Singh is actually his name, Dr. Ron Singh. And so he's doing a thing right for glucose monitoring. They need people to engage patients. And so what would they say? Like how would they engage them? But it turns out I actually went to his blog and he had this blog entry about how to sleep longer by affecting the lights in your house and rooms like that. And like you wake up in the morning, go see some walk outside and all fun stuff. So that's kind of useful. It'd be nice to sleep well. And so that's a really simple book, super easy. It actually matches exactly those articles and walk you through in a fun way. And also, like I think what you're saying before on stuff is like, I've allowed the prompt to be wide enough so that when it can't answer from what he's saying, it'll go broader. And like we were saying, the cat thing, my friend did what cats are better than dogs. It goes broad. It took one sentence and it went broad on it, which is really, really cool. So it's I'm totally open for whatever kind of books make sense. So, you know,
Actually, time for one last question.
oh, sorry.
So how are you dealing with this kind of problem that you have, like cognition and hallucination when there is?
That's the fun part, right? So it's like so I'm in the middle of this right now. Like I have my prompting going through. I'm trying to be really specific and tell exactly what to do, and it gets it wrong pretty often.
So the temperature is very less, like you're not telling it to get creative.
Oh, do what, sorry?
The temperature settings are very less, meaning you're not telling it to get creative, like go broader and.
So you can. So this is the author part. And so what happens is that there's a generic, I mean, right now I have one template, the generic template going through there, that pulls in a bunch of other data to make a bigger template on there. And on top of that, we have authoring tools. So the author can go there and say, you know what, I'm going to be more specific for this one specific section here. I'm going to tune it more on that one. And so we have tuning on the welcome messages. We have tuning on what qualifies leaving a section. And, you know, it's whatever makes sense to throw in there. But it's hard. The hallucinations are hard. Like I look at this thing and my instructions were so clear and it still can't get them. It gets them wrong often. But the thing about it though is that when it's talking to you, OpenAI is really good at like having a natural conversation. It recovers pretty well. And it's like, you know, it's a pretty pleasant experience.
And
oh, sorry.
You're trying with authors to get these books like copyright.
Yeah, that's the big question right now. So I think for me, like one of the earlier ones I was looking at, I think this is more like YouTube. When YouTube first started off, so videos were horrible, right? And so